And is at certain points in this sort of exercise, there are math problems for you to solve. Those math problems are in the packets that you have. I will also leave them up on the board. And so if you are really, really good at math, which means that, and you remember it, which means you will probably be able to blow through these in about 2 seconds, I would ask you a favor of you, which is to help the person next to you if they don't know. Okay? Because it will be hard for me to get around to everybody if you're having problems. So what the way this module will work is we'll talk a little bit about sort of how you do it, and then you're going to do it. All right? And then to be clear, let's see, I'll probably ask someone else to come up and solve it. So be prepared. I will probably, we'll see how that works. If it fails disastrously, then I will take control of the class again. But what I'll probably do is have someone come up and say, this is how I solved it.
Great.
All right? So linear relationships. So these are things that are linear, straight line. Okay? These are fairly simple in terms of math. They're probably the simplest thing to get. So here's your example. Did I give you this one? Nope, that's not. That's okay. So here's an example. Actually, I want to get rid of one of these screens. Catherine, do you know how to get rid of one of these? Awesome. Thank you. Just because I want to use, let's use the right. If you can get rid of the one on the right, that'd be great. Thank you. So here's an example. 7 minutes, based on historical data, it takes 7 minutes for the ambulance.
Thank you.
To get ready to go, and then 1.5 minutes per mile. So this is a linear relationship. Okay? And based on this information, we can figure out sort of how long is it going to take to get somewhere if we know how many miles away it is. Right? So essentially, we could do a graph, whatever, but there are certain elements to this line. There's the fixed and there's the variable. So this is fairly common in most of the math you're going to run into, even in micro, where there are fixed aspects and variable aspects. And so in this case, the time to get there is 7 plus 1.5 times the distance in miles. Okay? So there's my equation, y equals 7 plus 1.5x. All right. So that is a model using the linear relationship for my ambulance. All right. So there it is in graphical form. And by the way, you'll get these slides as well. So online, so you can refer back to them again if your math is maybe a little rusty. So in general, lines have a particular format. Y equals mx plus b, which might be bringing back nightmares for some people. Oh my God, I thought I had gotten away from that. Sorry, it's back. So we also talk about dependent and independent. So y is my dependent variable because it is dependent on x. In other words, in order to calculate y, I need to use x. In this case, if I want to know how long it takes the ambulance to get somewhere, I need to know how far away it is. So x is the independent variable. In economics, you would call it the exogenous variable. So it is given to you, it is outside the model. Whereas the time to get there is what would be called the endogenous variable. It comes from within the model. So I get it from the model. So a little bit of terminology. B is the y-intercept. So if we go back, sort of it is the y. B is the y-intercept. Okay? In this case, it was, if we go back to the model, it was 7. M is the slope. So if you remember, rise over run. Change in y over change in x. Lots of different ways to say it, but that's essentially what it is. In a linear relationship, the slope is constant. It's always this m here. Okay? Everyone good with me so far? No brains exploding. Awesome. So this is the slope of a non-vertical line. Okay? Why is it only a non-vertical line? Anybody remember? Pardon? Yeah, you can't divide by 0. So a vertical line, so straight up and down, there is no run. There is no change in x. So it's you get it divisible by 0, which means it's infinite. Okay. Use change because the sign matters. So be very careful when you're doing these things, because if you go from A to B versus B to A, you may get different things going on. Okay, so rise over run. So calculating the slope. Essentially, if you are given 2 points, which this is going to be your first exercise, if you're given 2 points, you should be able to calculate the slope of that line. Make sure that it's linear. Okay? So there you go. First one, find the slope of that line. I think this is what you've got, right? There you go. All right. Work in groups if you want. If you don't want to work in groups, I don't care. If this is... Yeah, this is the part where I would expect talking. All good? Ladies done? Awesome. Pardon? You're good? Okay. Figured I would ease everybody into the math. Okay, does anybody need more time?
God damn it.
So what'd you get?
I want to make sure that there's...
1/3. Anybody get something different, like 3? Because if you got 3, what does that tell me? You did run over rise, yeah. All right, so you could also plot it, like if you were given the graph. Typically in the classes you'll take, you're probably not going to be given the graph. You'll probably have to graph it yourself if you want to. But you could figure it out from the graph as well. So one of the applications that you're going to see is in your econ class, especially the micro, is the application here really is what's called a demand function. So if you've never had, so who has never had an econ class before? Show of hands. Oh, awesome. Okay. You're in for a treat. Okay, I'm biased. I teach econ, so I love it. You're gonna have so much